Okay, let's try this example. We're going to make a scatter plot and then get the correlation, and I'm going to do all that with my Texas Instruments calculator, but it does say make the scatter plot by hand, and you would want to be prepared to be able to do that on an exam. So that might be a little challenging on the computer. Let's see what I can do. Okay, so let me give this a try. Okay, I've got a tablet, but even with it, it's not on the screen, so forgive me for how messy this is going to be. But for a scatter plot, if you have positive variables, usually you want to make more of an L-shaped axis. Then you have to look at your numbers. And again, we need to pick which one's explanatory, which one is response. We've got powerboat registrations and manatee deaths. I think the logical choice is that the more powerboats there are, they might be leading to more manatee deaths. So I'm going to put powerboat registrations here. Okay, and these are in thousands. Okay, so forgive me for the bad handwriting there, but we got powerboats in thousands. Let's see, I'm going to go up here and do manatee deaths. Sorry. Alright, so you get the idea there, even if my handwriting's terrible. So then I have to look at the numbers. These are in thousands, but I see numbers. I'm looking back at the table, and you could go back in the video or the notes. We have 400s and 500s. So I'm going to count by 100 out to 800. That should get the job done. So let's say we got 100, 200, 300. And these are in thousands, but like 400,000, 500,000, 600,000, 700,000, 800,000. I think that'll cover all of them. And then the manatee deaths, the numbers are in the tens. I see a 50, I think, is the highest. So let's go over here. 10, 20, 30, 40, 50, 60, and I'll stop there. And then you just plot the points. So I have 447, 13. Okay, so 447. So I got to approximate about halfway. 447, 13, maybe somewhere around there. 460, 21. Okay. And there's a lot of these, and I don't want you to have to watch me do them all, so let me pause and finish. Okay, so there's my scatter plot, again with this terrible pen here on the computer doing the best I can, but we've got our horizontal and our vertical axis. You put your explanatory variable on the horizontal axis, so we've got our powerboats in thousands. We have 100,000, 200,000, so forth. You just need to make sure you cover like from the minimum to the maximum there. So I went out to 800. The largest value in my table was 719,000. So I get my last point there. And similar with your vertical axis, we put the response variable manatee deaths. Those go up to 50 if you look in the table. So I went up to 60 by 10s there. And then you just plot the points. And so it's going to be a lot better if I do this with graph paper, if I'm doing it by hand, or with a computer is going to give me a much more accurate picture. But not a bad picture there. We can definitely see it's going to be a strong positive relationship. The more registered powerboats, the more manatee deaths that there are. Okay, so let's go back to the problem. So made a scatter plot. It looked like it was a strong positive relationship. We're going to find the correlation coefficient. I will go ahead and also make the scatter plot with the calculator. I can get that just as quickly when I do the correlation. And then I can already do part D, explain in real world terms what this tells us about the two variables. Well, it looks like as the number of powerboats increases, registered powerboats increases, the number of manatee deaths is going up, which makes some real world sense. Okay, so I've got my TI Smart View here, the official Texas Instrument emulator for our calculator, and I'm going to enter these in. So stat, edit, and since it's two variables, we want to use L1 and L2 for these. You can use any list that you want and tell it the names later, but it's easier to use L1 and L2. So I'm going to pause my calculator, pause my video, type all these in, and then resume. Okay, so I just took the time, typed all those in. So you have two lists, and it's important that they line up. Okay, these are input and outputs. Okay, so I have 447, and beside it there in L2, 13. That's representing the point 447, 13. Then I have 460, 21. Okay, sometimes you run things, you get a dimension mismatch error when you try to do this with lists that aren't the same size because you accidentally miss one. Okay, so these two lists should be the same size, We should have our inputs and outputs lined up. So pick which one you think is your explanatory variable, put that in L1, take your response variable, put that right beside it in L2, and then let's go ahead and do the scatter plot. Okay, so let's hit y equals and make sure that that's clear it out if it's not, and then do second and y equals. I'm going to go into plot 1 and turn it on. Yours might already be on from previous sections, and it's the first picture there. Okay, we're going to do the little scatter plot. Scatter plots are two variable graphs, so we need an X list and a Y list. By default, I got L1 and L2. Again, if you put them somewhere else, let's say you did L3 and L4, you can do second and 3 to tell it it's an L3. Okay, but it's easier if you just leave things alone, do L1 and L2. You can pick your mark. The simulator is actually the color version. I can pick the color as well. A lot of you may not have that, but maybe you do. But that's all you got to do to set it up, and then you can do your own window. Let's do that. Let's hit the window button, and again, looking at the data, when I drew it by hand, I started at 0, but let's do instead the lowest. I think we'll cover them off. We do 400 for our minimum and 800 for our maximum in the X direction, and let's count by 100 to do that. And in Y direction, we got to go past 50, so maybe I'll leave the -10, but do up to, I'll go all the way up to 100 by 10s. Okay. Again, it doesn't matter exactly what values you pick as long as you see all the points in the window, and then hit graph, and there you go. Okay. There's a shortcut if you don't care exactly what your window is. You can do zoom and number 9. Okay. And depending on your version of the calculator, you may have to scroll down to see it, but number 9 is zoom stat. That'll take into account the data and make sure it all fits in the window. So a quick way to make sure you're seeing all your points is just hit zoom and number 9, and it'll pick some sort of window that shows all of them. Goes a little beyond the max and the min in each direction. So there's our nice calculator generated picture. Definitely a strong positive relationship. We can verify that with the correlation coefficient. First thing we have to do is turn that on. Okay. I'm going to show you first the traditional way here, which may be the only way depending on your version of the calculator, is to go into the catalog. For some reason, by default, when you buy one of these calculators, they've got it turned off where it doesn't show the correlation coefficient. So I'm going to hit the second button and then 0, which says catalog above it, and I'm going to go and find something that says diagnostics on. I can jump a little quicker if I do alpha and D here. And go and find one. So it's pretty far down in the list here, so it takes a minute to do this. You only have to do this once or until your batteries die again. I always hit the button too many times and off it goes. But find the one that says diagnostics on and then hit enter twice. Hit enter to pick it, enter to run it, and that does diagnostics on. I think they've added in the mode, if you hit the mode button on some of your calculators, this may only be on the newer ones, but if you scroll down, and again this one's showing a lot more than my handheld calculator does, you have to scroll down to see the rest of the stuff. They've shrunk the font and fit a lot of it on here, but down there's a diagnostics off and on. So in the mode, some of you might be able to toggle. I think a lot of you are going to be able to toggle between off and on there. You have to turn diagnostics on or your calculator will not show you the correlation coefficient when you run the least square regression. Okay? But let's do that, and then second and quit. So I have a calculator that has diagnostics on, and then I hit the stat button and go to calc, and then you can use number 4 or number 8. Okay? They do this, Texas Instruments does this because they want to be able to match everybody's textbook, I think. If you look at number 4, it says it's a linear regression and it's AX plus B. Okay? So slope of A, a y-intercept of B. That's kind of the algebra approach, like MX plus B, but using AX plus B. The modeling approach is to do A plus BX, to start with a value and add copies of the slope. If you look there, they're doing the exact same thing, but they are reversing A and B. They are reversing the slope and the y-intercept. If you use number 4, A is your slope, B is your y-intercept. If you use number 8, A is your y-intercept, B is your slope. Doesn't matter which one you use as long as you're careful there. When you do linear regression, I'm kind of getting ahead of myself. In the next section, we'll do linear regression. But that's also how we get the correlation coefficient on the calculator. We run that. So hit enter. Okay, if you've got an older calculator, an older version of the operating system, it may just pop up on your home screen and say linear regression AX plus B. Okay, if it does and you use L1 and L2, just hit enter and it'll give you the output. Mine gives me a menu where I can pick where I put those things. We got L1 and L2. Always in this class, leave frequency alone. We could store the equation. I'll show you how to do that. We can tell it Y1. It's if you have a newer calculator, you can hit alpha and one of these buttons. I forget which. Let's try alpha and zoom. No. Alpha and trace gives me a shortcut menu to get Y1 there on the newer calculators. But on all of them, you can hit the variables button. It's kind of buried in the menus here, but variables, and then go over to Y variables, and number 1 for functions, and there's the Y's for the graph. You can pick Y1. If you do that, it'll store the equation in Y1 and add it to the graph if you want to. That's kind of optional, but we're going to do the linear regression with L1 and L2. Calculate. It will output the formula. So we've got y equals ax plus b. That's our best fit line. It gives you the slope and the y-intercept for that. Then it gives you r, which is your correlation coefficient. So for this one, 0.94, very strong and positive. It also gives you r squared. We'll talk in the next section about what r squared tells you. That's called the coefficient of determination, and it also gives you some meaningful information. So the calculator gives you both of those. But that's how you get your correlation. Okay? So go Stat, Edit, enter your data into L1 and L2, and then go to Stat, Calc, and run number 4 or number 8. Okay? Again, either one will do it. Don't run number 9. That's the natural log, not linear. You need the LIN. So if I run number 8 with L1 and L2, I'm not going to store the equation this time. Calculate, and I get my result. Okay. If you do store the equation, and I did a minute ago, if you hit y equals, it puts it in there with tons of decimal places, and you can see it on the graph.